What we were looking at before was areas of polygons and stuff like that. We're going to move away from polygons now and start talking about circles again. But as we start talking about circles again, I think it's important to take a couple minutes just to review something that we did with arc length just about 2-3 weeks ago. This is a formula that kind of bothered people. We'd be looking for like the arc length of this circle right here. And what we kind of figured out about that is the arc length is a portion of the entire circumference. That there's a relationship there. And that when we related the arc length, which we abbreviated with an L, over the circumference, which was pi times diameter, we related that to the measure of the central angle versus the whole circle. And that was the proportion we set up. And that proportion was useful for us so that we could either find the unknown arc length or maybe the diameter or radius of the circle, or sometimes if we knew these two, sometimes you had to find the measure of that central angle. So we could use that proportion to solve for almost any unknown that we had. Now in this case, it's just the arc length. So all we have to do is we put our central angle in, 120. Whoops. Love when it does that. It's 120 over 360. Arc length is what's unknown, so we put that on top. Now, the circumference of the circle, we do know the radius is 14, so the diameter is 28. So 28 pi. Reduce this fraction, which is 1/3, equals arc length over 28 pi. I could cross multiply, or I could just multiply in this case by 28 pi. Cancels, and I get the arc length was 28 pi over 3, and it was centimeters. By the way, on the quiz, a lot of people kind of forgot about units, especially on the back page. Not, I shouldn't say a lot, but a few people did. So just be careful. Remember, we're always using units from now on.
Yeah, it's not like if there's nothing there, you use units squared.
You can use U for units or centimeters or meters. I don't care. You could, if nothing is designated, you may use the unit of your choice. Okay. I would keep it something standard, or if you don't want to use a standard, inches, centimeters, meters, just use U for units. Measuring in bananas probably isn't going to be useful for us. Okay. That would be a standard. Now, what we're doing.
I'm just curious. How big is an acre?
I used to know the exact measurements of that. It's like 150 by 150 feet or something like that.
So it's not that big.
Not really. Yeah, it's big enough. I don't know. I'd have to look it up. I'd have to look it up. But we'll get to that later, okay?
Yeah, I was just curious.
Later, at the end of the period, maybe I can look that up. All right. What we're going to do today with area of a circle is the same idea. It's just that instead of the area formula for this is so similar. Because one of the things obviously we're going to be interested in is what's the area of this slice of the pie? Okay? What's the area of just that slice? And we're going to use almost exactly the same formula. Theta over 360, except instead of arc length here, now that's going to be the unknown area of the sector. We call that S. And what are we going to put down here instead of circumference? We're going to put, area of the circle, right? Because this is distance, and this is a distance, so a distance compared to a distance. Right? We did an angle compared to an angle is a distance compared to a distance. So now we're going to go an angle compared to an angle is an area compared to an area. When we start dealing with area of a circle. So we're going to get there. But first, let's figure out how do we find the area of a circle? What's the formula for that? So that's step one. Well, we all know the formula for area of a circle, don't we? Pi r squared. It's a pretty straightforward formula. We use it all the time. It's not one that you have not seen before. You've definitely seen pi r squared before. A lot of people get confused between r squared and 2r. R squared normally does not equal 2r. The only time r squared equals 2r is if r equals 2. Okay? 2 squared equals 2 times 2. That's the only time it works. For any other radius, 1, 5, 18, the square root of 7, I don't care, whatever it is, anything other than 2, 2 squared, or x squared and 2 times x are not the same thing. 7, for example. 7 squared is 49. 2 times 7 is 14. They're not the same. Do not confuse multiplying by 2 with squaring. And for undoing, remember, we can't undo squared. I've seen this several times from people. I've seen people say like x squared equals 16, and instead of taking the square root to divide by 2, they go x equals 8. Remember, to undo squared, we need square root. Not 8. So don't confuse squaring with times by 2. Don't confuse square root with divide by 2. They are different. And it's an easy mistake to make. People make it all the time. But we want to avoid it if we can. So here I have a circle. Okay, the radius of the circle is listed at 8 inches. If the radius of the circle is 8 inches, what's the area of the circle going to be? Area is formula pi r squared, right? 8 is the radius, so that's 64 pi inches squared. Mm-hmm. If we just have whole numbers, a lot of times we'll just leave it as 64 pi. Honestly, it's easier. I don't have to multiply it, get out a calculator and do 3.14. If it's decimal values involved, sometimes we'll change it. And oftentimes you'll see in instructions either leave in terms of pi, which means leave it written that way, or if there are decimals in the problem to begin with, they'll say approximate it. And then use 3.14 in the calculator. Now, I'm not going to ask you a whole lot of questions to deal with, here's the radius, find the area of the circle. Because that's pretty easy stuff. I'm more likely to work it backwards. But again, this is just good practice because we often need to work our formulas backwards. Or use our formulas to find a certain unknown. So I say the area is about 78.5 meters squared. Find the diameter of the circle. Notice this keyword right here, about. That's telling us approximation. And the decimal in there is also telling us approximation. But we're going to approximate this. But as usual, what I like to do, what I tell people to do to avoid errors, is start with a formula. Write out the formula you're going to use. Then put the numbers in where they belong. The area is 78.5, so 78.5 is A. Pi r squared. Well, now I can divide by pi, which is 3.14, because it's about, we're going to approximate that, and I get r squared is 25. So if r squared is 25, then r equals 5, not 12.5. Okay, but is that the answer that we need for the question? No. The diameter of the circle. The diameter is 10 what? Meters. Always units. Just a little hint for people. And this is just something that came up actually at the conference over the weekend as a reminder. Something I haven't reminded you of lately, but I should. Always go back and reread the last few words of the instructions because they usually tell you what the question is. And you make sure you're answering the actual question. And if you get big, long story problems ever in standardized tests or homework or stuff like that, just read the first sentence that kind of sets it up and read the last sentence because the last sentence usually tells you what you're looking for. All the mumbo jumbo in the middle sometimes is really useful, sometimes it's not, especially in a multiple choice test environment that you see a lot on your ACTs and stuff like that. A lot of times, if you just know what the first sentence is and what the last sentence is of the question, you can usually narrow down your answer choices pretty quickly. But always know what you're looking for. All right, a circle has an area of 80 inches squared. Find the exact value for the radius. So we're looking for the radius, exact value. That means no approximation. So again, area is 80 pi, is pi r squared. Well, I divide by pi, and lo and behold, the pi's just cancel right out. So that's nice. So r is the square root of 80, which is the square root of 16 times the square root of 5, or 4 root 5, and the unit was inches. Is that what I'm looking for? I wanted the exact value of the radius? Yes. It is never a bad idea, especially, again, I know it's hard to do it every day in your homework or on just your benchmark quizzes and stuff like that, but when you're taking standardized tests, when most of you are going to be taking your ACT, some of you might be even starting this summer, it's not a bad idea to read with a pencil in your hand or a highlighter and do things like that. Mark off, what am I looking for? I want the exact value of the radius. And highlight that as you're reading it so you remember what it is you're looking for so you don't make a mistake by picking an incorrect answer. This is a sector area situation. It says find the shaded area. The shaded would include the 128 if you want to shade over that. So, actually, you know what? I can make that even nicer. I can shade it more accurately if he's a highlighter. Yay. I try to keep it inside lines here. Pretty good. I did fail kindergarten. I do not do well at staying inside the lines. But it's okay. I can live with that. It's a shortcoming I'm willing to tolerate in myself. Okay? So again, find the shaded area. What do? Same thing. Angle over angle, 120 over 360, equals area over area. Sector area, which I do not know, I'm going to call that x, over total area, which would be what? 49 pi centimeters squared. This is going to reduce 1/3. We're going to cross multiply. 3x is 49 pi, so divide by 3. X is 49 pi over 3, and it's an area, so centimeters squared. Okay? I get no real reason to approximate that. That's fine. But you see how these things set up? It's not too bad. But you do have to know area of a circle, pi r squared. I mean, that's pretty obvious. That's something that's going to be important. One more. Ice cream cone shape. Okay? Now, we do need to find some stuff out about this. This is an ice cream cone, so these are each 13. If this is 10, how long is this side right here? 5. So I can find the altitude of this triangle by using Pythagorean theorem, right? 5 squared plus x squared equals 13 squared. I don't need SOHCAHTOA there. It's 169, so x squared is 144. So x is 12 centimeters. Now here's where I saw a lot of mistakes in the test. People did that and it said find the area. And you know what you did? You didn't divide by 2. You didn't do base times height divided by 2. You just did base times height. So be careful with that. Base here is the whole side, 10, times height, which is 12, divided by 5. How about 2? So that's 60 centimeters squared. Now that's just this area. Okay? I need the ice cream portion on top. So in order to find the ice cream portion on top, I've got to find the area of the whole circle, but I don't have a whole circle. I only have a half circle. So if I find the area, I'm going to divide that area of the circle by 2 when I'm done, right? So what's the radius of the circle? Radius is 5, so the area of the circle is pi times 5 squared, or 25 pi. So 25 pi over 2 centimeters squared. So that would be my total area. 60 pi centimeters squared plus 25 pi over 2 centimeters squared. Now, it may be in my best interest at that point to approximate that, so I can combine them. I can't combine them until I approximate them. Well, I could, but that's complicated. So 60 plus 25 pi over 2. So 60 plus 25 pi. Wait a minute. Helps if I put my glasses on and I can see what I'm doing. Where's my pi key? There it is. Divided by 2. It's 99.26, 99.27. Okay. And that would be the total area for that ice cream cone shape. So again, area of a circle, not a new concept to people. Sector, a little bit, but it's really just reviewing arc length formula. And there's a lot of common sense involved here. A lot of time needed to be spent just thinking through what's going on. But area of a circle is one of those formulas you're going to have to know. And the proportionality thing, again, that's something we've done before that you should already know. Just not with area. We haven't done it before, but proportions aren't a big deal. Okay.